Hello everyone. The topic is about condensers and it comes under the unit components of refrigeration. Condensers. Heat exchangers are used to transfer heat some processes like heating, cooling, condensation, boiling or evaporation. Different heat exchangers are named according to their application. For example, heat exchanger used for boiling purposes are called boilers. Heat exchanger being used to condense are known as condensers. The condenser is a heat exchanger that usually rejects all the heat from the system. The condenser accepts all the hot, high pressure refrigerant, usually a superheated gas, from the compressor. The condenser is usually air cooled by natural or forced convection to increase the cooling effect of the condenser. Function. The purpose of the condenser in the refrigeration system, it is to remove heat from the refrigerant vapor, leaving the compressor or generator in case of absorption system, so that the refrigerant will condense to its liquid state. The liquid refrigerant will then be able to achieve the refrigerating effect in the evaporator. Working of a condenser. In a typical refrigerant condenser, the refrigerant enters the condenser in a superheated state. It is then first de-superheated and then condensed by rejecting heat to an external medium. Then it may leave the condenser as a saturated or subcooled liquid depending upon the temperature of the external medium and design of the condenser. Here in the right side you can see the schematic diagram of a simple refrigerating system. In this there are there are totally four components. One is compression, suction line, evaporator and expansion valve. Sorry, four. And in this we can see the gas, it passes from compressor to a condenser, then to a receiver, that is expansion valve, then evaporator. In this the heat is absorbed in the heat is absorbed in the condenser and it gets evaporated in the evaporator. Here the cooling takes place in the condenser and heating takes place in the evaporator. Classification. Condensers are classified into three types: air cooled condensers, water cooled and evaporative. In air cooled condensers, it is natural convection air cooled condensers and or forced convection air cooled condensers. In water cooled, it is tube and tube or double tube condensers, shell and coiled condensers, shell and tube condensers. And third, in evaporative, there is no classification. Air cooled condensers. Air cooled condensers, in this air is used as a fluid for cooling purpose, that is refrigerant rejects heat to air flowing over a condenser. First one, it is natural convection type. The finned type condensers are mounted either below the refrigerator at an angle or at the back side of the refrigerator. In case it is mounted below, then the warm air rises up and to assist it an air envelope an air envelope is formed by providing a jacket on backside of the refrigerator. The fin spacing is kept large to minimize the effect of fouling by dust and to allow air to flow freely with little resistance. A thin wire are welded to the serpentine tube coil. The wires act as for increased heat transfer area. Wire and tube type condensers commonly used in domestic refrigerators. Hence, these condensers are used for small capacity refrigeration systems like household refrigerators and freezers. Second is forced convection. In forced convection condensers, the circulation of air is over the condenser surface, which is maintained by using a fan or a blower. These condensers are normally uses fin air side for good heat transfer. The fins can be either plate type or annular type. Forced convection type condensers are commonly used in window conditioners or air conditioners, in water coolers and packaged air conditioning plants. In forced convection type, refrigerant passes and the refrigerant comes out through the plate fins. Next, water cooled. In water cooled, is divided into three types. First, it is double type tube or tube and tube type. In double pipe, condensers are normally used up to 10 tons of capacity. The cold water flows through the inner tube. Refrigerant flows through the annulus in counterflow. Headers are used at both ends to make the length of the condenser small and reduce pressure drop. The refrigerant in the annulus rejects a part of its heat to the surroundings by free convection and radiation. The heat transfer coefficient is usually low because of poor liquid refrigerant drainage if the tubes are long. Second is shell and coil type. In this, the condensers are used in systems up to 50 tons capacity. The water flows between multiple coils which may have fins to increase the heat transfer coefficient. The refrigerant flows through the shell. In smaller capacity condensers, refrigerant flows through coils while water flows through the shell. When water flows through the coils, cleaning is done by circulating suitable chemicals through the coils. Shell and tube type. It is used for systems up to 2 tons to 2000 2 tons up to thousands of tons of capacity. The refrigerant flows through the shell while the water flows through the tubes in single to 4 passes. The condensed refrigerant collects at the bottom of the shell. In this, the liquid refrigerant is drained from the bottom to the receiver. A vent connecting the receiver to the condenser for smooth drainage of liquid refrigerant. The most common type is horizontal shell type. Vertical shell and tube condensers are used with ammonia in large capacity systems so that cleaning of tubes is possible from top while the plant is running. Next, about evaporative condensers. In this, both air and water are used to extract heat from the condensing refrigerant. Evaporative condensers combine the features of a cooling tower and water cooled condensers in a single unit. In these condensers, the water is sprayed from top out on the bank of tubes carrying the refrigerant and air is induced upwards. Therefore, there is a thin water film around the condenser tubes from which evaporative cooling takes place. The heat transfer coefficient for evaporative cooling is very large and it can be operated at low condensing temperatures, about 11 to 13 K above the wet bulb temperature of air. The role of air is primarily to increase the rate of evaporation of water. The required airflow rates are in the range of between 350 to 500 meter per hour per refrigeration capacity. Thank you.